Chapter 6.3, Solving Systems Using Elimination. Your objective for this chapter is to solve systems by adding or subtracting to eliminate a variable. Example 1, they're telling you to solve the system by adding the two equations. The reason we're going to add is because one is positive 5y for y and the other term for y is negative 5y. So if we can add the two equations together, the 5y's will cancel. So you're going to add vertically. 2x plus 6x is 8x. 5y minus 5y goes away because it's 0y. And 17 minus 9 is 8. Then just solve the new equation you've created for x. So you're going to divide both sides by 8. And you get that x equals 1. That's step 1, and that's to solve for the first variable. After you have the first variable, you're going to take it and plug it into one of the original problems for x. So 2 times 1 plus 5y equals 17. And then you're going to solve for y. So 2 times 1 is 2 plus 5y equals 17. Subtract 2 from both sides, so you get y equals 15. Divide both sides by 5, and you get y equals 3. Which means the point where your two lines would cross is 1, 3. That's your solution set. Guided practice number 1, I want you to try on your own. You have to show all the work yourself, but I will give you the answer. Pause the video and resume it when you're ready for the answer. All right, guided practice number 1. You should get 2, 7 as your answer, but you have to show your work. So I'm going to write must show work. If you're just copying what I have up here, you are going to get the whole example wrong. All right, example 2, we're going to solve a system by subtracting. A theater club sells a total of 10 tickets, or has 101 tickets to its first play. A student ticket costs $1, an adult ticket costs $2.50. Total ticket sales are $164. How many student tickets were sold? So my first equation is going to be student tickets plus adult tickets equals 101 tickets total. My second one is going to be a student ticket, which is $1, times the number of student tickets plus $2.50 times another number of adult tickets equals $164. So I really have S and S. They're both positive. You can add them if they have opposite signs, but you have to subtract them if they have the same sign. So we're going to run through that whole bottom equation and change the sign of everything in the bottom equation. Then we're going to combine the two equations together. So S minus S cancels. 1A minus 2.5A is negative 1.5A. And then 101 minus 164 is negative 63. Then divide both sides by negative 1.5. And I get A equals positive 42. Step 2 is always to take it and plug it back into the original. So if I sold 42 adult tickets, how many student tickets did I sell? I'm going to subtract 42 from 101, and I get 59. The question was how many student tickets were sold, so your answer is 59 tickets. You don't have to give both numbers here because they're not both answers. All right, guided practice number 2. You're going to set it up just like I did over here and solve it. Resume the video when you're ready for the answer. All right, it takes 20 minutes for a car, and it takes 30 minutes for a truck. But you have to show your work. If you only write down what I have written down, you're going to get it wrong. Example 3. We're going to solve using an equivalent system is what this is called. What we're looking for to be able to eliminate is we want to have either the same, like let me go back up. For example 2, I had the exact same variable. When I did that, I subtracted. But for example 1, I had opposite variables, positive 5y, negative 5y. So when I had that, I added. But here, for example 3, I have negative 2x and 7, which are not opposites and they're not the same. And I have 15 and negative 5, which are not opposites and they're not the same. So I can't just add or subtract here. I'm going to have to think strategically. I want to force them to be the same number or opposites. So what you really want to ask yourself is there something I can multiply one number by to get the other number or the opposite of it? And 2 and 7, there's nothing there, but I can multiply 5 by 3 and get 15. So I'm going to multiply the whole bottom equation by 3. And that's going to give me 21x minus 15y equals 17. Then I'm just going to rewrite the top equation because I didn't change it at all. And cancels, and I get 19x equals negative 32 plus, I was supposed to multiply 17 by 3, and that's supposed to be 51. So it's negative 32 plus 51, which is 19. And then you divide both sides by 19. So you get x is 1. Once you find one variable, you have to take it and plug it back in to find the other one. So that's going to be negative 2x is going to be negative 2 times 1 plus 15y equals negative 32. And solve for y. So we're going to add 2. We get 15y equals negative 30. So y is going to equal negative 2. So your answer is 1, negative 2. All right, try guided practice number 3 on your own. I will tell you that you probably want to multiply the top equation by 3 to make this be negative 6y, so they'll cancel. Resume the video when you're ready for the answer. All right, for guided practice number 3, you should get negative 2, 2. But you have to show your work or you won't get any credit for that example. So far, if you don't show your work on 1, 2, or 3, you'll get a 0. All right, now example 4, it gets a little bit harder. We are going to have to multiply, but if I multiply 3, I can't get 4. And if I multiply 2, I can't get 3. So I'm going to have to multiply both equations. The easy thing to do is to multiply the equations by the other coefficient. So if I want to eliminate the x, what I can do is multiply the top one by 4 and the bottom one by 3. So and then since they're the same sign, we want to make one of them negative. So let's multiply the top one by negative 4 and the bottom one by 3. And that gives me negative 12x minus 8y equals negative 4. And then 12x plus 9y equals negative 6. Now we're going to add the two equations together. So those cancel, and I get y equals negative 10. Now we're going to take y, we're going to plug it back into one of the originals, and I'm going to use the first one. So it's going to be 3x plus 2 times negative 10 equals 1. And then you just solve. So it's 3x minus 20 equals 1. Add 20 to both sides, and you get 3x equals 21. So x must be 7. So I know that x is 7 and y is negative 10, so my answer is the point 7, negative 10. All right, guided practice number 4. I will tell you that I would either multiply the top. I would multiply the top by 2 and the bottom by 3, since these are opposite signs. That way you'll get positive 6 in the top and negative 6 in the bottom, and the y's will cancel. Do that and then resume the video when you're ready to see the answer. Okay, your answer should be -4, -1. But if you don't show your work, you will get that example wrong. All right, example 5. We are going to find the number of solutions. All they want to know is how many solutions does the system have. So let's investigate. Up here I've got +2. Down here I have 1. Then I have +6, +3. So if I wanted to eliminate, I'm going to have to multiply one of the equations. So we'll multiply the bottom by 2. And since they're the same sign, we're going to make it negative. So they'll be opposites. So the top equation I did not change. I'm going to leave like it is. The bottom equation is going to be -2x minus 6y equals -18. Then those are going to cancel, and you get, actually everything cancels. So you get 0 equals 0. If you get something that's always true, your answer for the system is all real numbers, or infinitely many. Not all real numbers. It's infinitely many solutions because they're the same line. So the lines lie on top of one another. So that's infinitely many solutions. If you were to get something that's not true, let's say 0 equals 12, then your answer is no solution, which means they're parallel lines and they don't cross. All right, answer number 5. If you get something that's true at the end, it's infinitely many, and if you get something that's false, it's no solution. I'm not going to give you the answer for it, since I kind of just did. Show your work, and then either put infinitely many or no solution. Bring this tomorrow to be checked, and be ready for a quiz at the beginning of class.